Hello everyone and welcome back to another video in the Introduction to Memory Forensics series. This time we're going to take a look at Redline, a free analysis tool from FireEye that allows us to analyze a potentially compromised Windows system. Redline can collect and analyze memory and disk-based artifacts, including all running processes and drivers from memory, file system metadata, registry data, event logs, network information, services, tasks, and even web history. It provides an easy-to-use GUI interface that can help us analyze that collected data to find evil on a given system. As of the recording of this video in September of 2017, the current version of Redline is 1.20, released in May of this year. Version 1.20 makes some important changes, including adding support for the collection and analysis of Windows 10 machines. This version also speeds up initial load times by removing a feature called MRI, which I've mentioned in previous videos. MRI, or Malware Risk Index, was a 1 to 100 scoring system that could help us easily identify potentially malicious processes running on a system. For example, if an svc host.exe process was found with an unexpected parent, in other words, not services.exe, or unexpected parameters were seen after the -k flag, or perhaps it was located outside of system root /system32, you could expect any one of those things to cause Redline to flag it with a high MRI score, probably somewhere in the 90s. I actually found this useful for what I like to call point-and-shoot forensics. At the very least, it gave us the ability to quickly find low-hanging fruit. So maybe FireEye will give us the option in the future to re-enable this feature, but for now it's simply not there. In the next section of this video, we're going to switch over to our Windows 10 analysis VM and create something called a Redline collector. A collector is a series of scripts that will automate the collection of forensic data from a target system. Let's switch over to the Redline user guide so we can get some more information about Redline collectors. There are actually 3 types of Redline collectors available to us, and the names are pretty self-explanatory. We have a standard collector, a comprehensive collector, and an IOC search collector. With any of these 3 collector types, we have the optional ability to acquire memory, which I would almost always suggest that you do. The standard collector will configure scripts to gather the minimum amount of data necessary to complete an analysis. The comprehensive collector, as you might imagine, will actually gather most of the data that Redline is able to collect and analyze. According to the manual, this should be used if you intend to perform a full analysis or if you only have one opportunity to collect data from a computer. And then lastly, the IOC search collector will actually collect data based on indicators of compromise that you provide to it. If you're not familiar with indicators of compromise, this could be anything such as hashes, IP addresses, domain names, or anything else that we have seen from previous incidents that would enable us to preemptively find evidence of malware or evidence of an intrusion in the future. We're actually going to be creating a comprehensive collector on our Windows 10 analysis VM, and we'll save that collector to an external USB flash drive. We'll then run that collector on our target VM to gather the forensic data, and then bring the results back into Redline on the analysis VM and see what we've got. So let's get started. Okay, we are now in our Windows 10 analysis VM. You'll notice I've got an E drive titled Flash. This is the 64 gig exFAT formatted USB flash drive on which we'll be storing the collector that we're about to create. Currently, there's nothing on the drive. So let's go ahead and launch Redline. And when we do, you'll notice we've got 2 major sections, collect data and analyze data. Under collect data, you'll see options for creation of the 3 different types of collectors that we just covered. And under analyze data, you'll notice that we can open a saved memory file or a previous analysis session. And for convenience, the recently used analysis sessions are located right here. We're going to be creating a comprehensive collector and saving it to our USB flash drive. But before we do, let me show you a standard collector so you can see some of the differences between them. Under both the standard and the comprehensive collector, this screen is going to look mostly identical. We have the option under both to acquire memory image, and we're almost always going to make sure this box is checked. The real differences are here under Edit Your Script. When we click this, you'll notice we see 5 major sections of forensic data that we can configure for this particular collector. We've got memory, disk, system, network, and other. And if we choose the Show Advanced Parameters checkbox, we'll have additional options under each of these 5 sections, mostly relating to filtering. For example, here you'll notice that selecting the Show Advanced Parameters box allows us to filter on specific PIDs. We can even use regex to pattern match. For now, we're not going to worry about that, so we'll uncheck this. And you'll notice that under the standard collector and under the memory section, most things are selected by default. In addition to MD5 hashes, we can also tell it to compute SHA-1 and SHA-256 hashes, as well as MemD5 hashes, which are hashes of memory-based objects. And we can tell it to grab strings for processes as well. Under drivers, again, we can choose strings, and in addition to MD5, we can choose SHA-1 and SHA-256 hashes. We also have the option to acquire memory image, which again is the same as this checkbox that we already checked. Under disk, you'll notice nothing is selected for the standard collector. Under system, the only thing selected is machine and OS information, so no user accounts or prefetch, no registry information, no event logs. Under network, no ARP or routing tables, no browser information. Under other, none of these options are chosen either. So you can see that by default, a standard collector is indeed very bare bones. Now let's take a look at a comprehensive collector. You'll see the initial screen looks pretty much identical as I stated. We'll check the Acquire Memory Image checkbox, and we'll click Edit Your Script. You'll notice the memory section looks pretty much the same. Under disk, however, you'll notice almost everything is selected for the comprehensive collector. We can optionally choose strings, and in addition to MD5 hashes, SHA-1 and SHA-256 hashes. Under system, everything is chosen, so we will grab user account related information, prefetch, registry, and event logs. Under network, everything with the exception of 2 Firefox specific options is selected. And under other, most of these options are also selected by default. So you can see there's quite a bit of difference between the default configuration of a standard collector and a comprehensive collector. And as the Redline manual stated, if you only have one shot at acquiring the evidence, always use the comprehensive collector. And of course, always acquire memory. So we're going to leave everything at the default with the exception of checking this box. And now we'll click Browse, and we'll choose the flash drive and hit Select Folder. When we do, you'll notice a red message that says, please select an empty directory. So we are unable to simply save it to the root of the E drive. Let's click Browse again and create a folder. We'll call it Collector. When we do that and click Select Folder, you'll notice the path changes to E:\collector and the red message is now gone. I'll now click OK, and it's already done. We have now created a collector which has been saved to our USB flash drive. It tells us that we should run the run redlineaudit.bat script on the target machine. When we do so, the results will be saved under the Sessions folder within Analysis Session 1. If we run the script again, it will append the results to Analysis Session 2, 3, and so on and so forth. When we're done, it tells us to transfer the results back to our analysis machine, which is this machine, and then open the analysis session.mans file located within the specific analysis sessions folder. If I click this blue link, you'll actually see the files on the flash drive that have been created. The run redlineaudit.bat file is right here, and you'll see this simply executes a few of the commands to grab the particular artifacts that we told it to grab. You'll also see additional command files, batch files, VBS scripts, and JavaScript. And then we have a 64-bit and a 32-bit version of the xagt.exe file, which is a FireEye agent that's used in the acquisition process. And that's pretty much it. So at this point, all we need to do is go to our target machine, pop in the flash drive, and run the runredlineaudit.bat file to grab the data. Then we'll bring the results back to this machine and analyze them. So let's head over to our next section. Okay, welcome back. In between the last section of the video and now, I took that comprehensive collector that we created and I ran it on the target VM. It actually ended up taking a little more than an hour to complete. So to do that, I took this USB flash drive on which we created the comprehensive collector and attached it to the Windows 10 target VM. And then from the flash drive, I ran the runredlineaudit.bat file that you see highlighted here. This is a screenshot of the resulting operation. You'll see a cmd.exe window was spawned, and you can see xagt.exe along with these parameters being run. This is the window that stays up during the entire collection process, and at the end of the collection, you don't get a nice message telling you it's finished, it just disappears. You'll notice a reference to memorize audit script.xml. Memorize, M-E-M-O-R-Y-Z-E, is actually an older product from Mandiant, now FireEye, that actually allowed us to perform forensic analysis on memory images. So apparently Redline uses some components associated with Memorize still, which is interesting. So on the flash drive, you'll notice that a sessions folder was created that wasn't there when we just created the collector. And then underneath that, we see analysis session 1. Had there already been an analysis session 1, it would have created an analysis session 2, and so on and so forth. And underneath that, you'll see analysis session 1.mans, which is the file that we can double click to actually open it with Redline and begin the analysis. Under audits, you'll find the meat of all the data that was collected, which as you can see is mostly in XML format. So to speed up processing, I actually took this entire analysis session 1 folder and copied it locally to the desktop right here. And then I went ahead and preemptively opened it with Redline ahead of this recording because it takes about 2 or 3 minutes to do the initial load. Now when I open it, you'll see it's almost instantaneous. So now what we're going to do is take a look at the data that was collected for us by this comprehensive collector. Starting at the very top, you'll see some basic system information such as the OS and domain or workgroup in this case, the name of the machine on which the collector was run, which is Redline test, and the IP address. Underneath that, we've got 4 different options for our investigation. We can choose I am reviewing a triage collection from HX. So this is actually FireEye's endpoint threat prevention platform. This is a commercial product that if you have in your environment, it's nice because it integrates with Redline, or rather Redline integrates with it. We have I am investigating a host based on an external investigative lead, which is actually what we're going to be choosing because it most closely fits what we're trying to do. We've got I am reviewing web history data. If that happened to be the focus of our investigation and that's all we wanted to look at, we could choose that option. And then we've got I want to search my data within a set of IOCs. If we had developed said IOCs, we could then search this collected data for them. So we're going to go ahead and choose this as I stated. And on the left side, you'll notice the leftmost column says Analysis Data. This contains all of the data collected by the collector. And what we're going to do now is actually go down through here and quickly look at each of these sections so you can see the wealth of information that was able to be gleaned from this particular computer. Under System Information, we've got some fairly detailed information about the machine, the time zone it's in, the CPU and memory-related information, BIOS-related information, registered owner and organization, OS information, even the install date and the bitness of the OS, which is 64-bit in this case. Under Processes, you've got most of the memory-related data that was collected. So you'll see here, obviously, the processes that were present on the system. And across the top, you can see the process name, the PID, the path, the arguments, usernames, start times. Of course, you'll see the parent PID, hashes, all kinds of information that's extremely useful. Now, to pick on SVC host again, since it's so ubiquitous, as I previously stated, if we had a malicious svchost.exe process, and this was an older version of Redline, you would see it at the very top of this list, and it would be flagged in red with a high MRI score to make it easy to stand out and say that, hey, this may require further analysis. Unfortunately, that feature is removed in this version. But just as an example, with SVC host, you can see the expected -k parameter and what follows after that. And if we scroll across, of course, we can see the parent PID 596, which should correspond to services.exe, and a bunch of other information as well. Now, there's also a hierarchical processes view, which I like, because you can see it in a tree format, much like PS tree from Volatility, if you're familiar with that. So, for example, this particular svc host.exe process, we can clearly see has a parent of services, which has a parent of winInit.exe, and we can, of course, expand out the arguments section and see the -k parameter and the things that follow after it, the usernames associated with it, start times, all kinds of interesting information relating to the process. So, very cool stuff there. So now, moving back to the file system section, we've got a huge amount of information. So if we look at this, this is actually the file system that was present on that target machine. So on that machine, if I drill down into, let's say, the downloads folder, you'll see, well, there's a desktop.ini file there, but nothing too interesting. If I look at, how about documents? Okay, so we've got a default.rdp session. How about desktop? Is there anything on the desktop that might be of interest to us on this machine? And you can see there is. There's quite a few things on the desktop. Here's one called netcat.zip. That might be interesting to us. So if I double click on this, this will actually show us quite a bit of information about the file. It shows the file size, it shows the MD5 sum, and recall in the collector configuration, we could have told it to also calculate SHA-1 and SHA-256 hashes as well. You can see the username that owns it, the SID associated with it. So all kinds of information relating to all of the files that were present on the file system of the computer on which we ran this particular collector. So obviously this is very, very useful information, especially because now we have a hash of all of the files along with their size and their location, and obviously you can see how this will be quite useful. If we click on Windows Services, that's pretty self-explanatory. This is the services that were present on the system and their status at the time the acquisition occurred. You can see the stopped or running status. You can even see the mode. Was it delayed start, on demand, auto start, disabled, etc. If we click on persistence, we can see the persistence mechanisms that may be present on the machine. Anything from, for example, the current version run and run once keys that are so ubiquitous, to various other areas from which you could automatically start programs at startup. So persistence obviously would be a very good section to review. Under users, pretty self-explanatory. Those are the users that were present on the system. You can see these SIDs in the RID right here. So the RID of 1001 was the first user created on this box, which happens to be my account. Of course, 500 is always administrator, 501 is always guest, but you can see all of that information here. If we click on event logs, you'll never guess what we see. Event logs. The event logs here are shown as terms of their source. You'll see the type, informational, error, warning, so on and so forth. You'll see the timestamps associated with them, so obviously very useful information here. Under tasks, we'll see scheduled task related information, which is always something you'll want to review on a target system as well. Under ports, we'll see network related information. We can see any of the particular daemons that are listening and the TCP or UDP ports on which they're listening. We can see driver modules that were loaded. We can see the device tree. We can see our ARP entries, so we can correlate MAC addresses to IP addresses. So this is actually the ARP table. We can also see the route table on the machine. We can see prefetch related information. So let's pick on ccleaner.64.exe since that's been in the use quite a bit. So you can see this particular program was executed 39 times, last run on this date. So very interesting information here. This is not unlike some of the other tools that we've used to parse prefetch to show evidence of application execution, and Redline just does it for you right in the software. Under disks, we can see physical drive 0, which is the virtual hard drive, the C drive, and then physical drive 1 is the mounted USB flash drive that we have. Under volumes, you can actually see the volume names for those devices and their drive letters associated with them, along with bytes per sector and sectors and space-related information, and even volume serial numbers. Registry hives, of course, will show us the registry hives present on the system. And then the next 3 sections are always very useful. Browser URL history, so we can see all of the different sites to which this particular computer has visited. And we can even filter on that by searching for, well, let's pick on CCleaner again. If we search for that, you'll see that it highlights all of the downloads associated with CCleaner. And we can even, in addition to searching and highlighting, we can actually filter on URLs. So we can say, show me URLs that contain Google. So we'll add that filter, and then looks like someone was searching here, for example, for domain generation algorithm related information. And looks like CCleaner and Talos. So very interesting to be able to filter on things like this. If we click on cookies, we can do the same thing and look at cookie-related information. We'll see, of course, Google Analytics cookies and Microsoft Office 365 cookies here, and Symantec and Apple cookies and YouTube. And, of course, we can search or filter on any of these values as well. Under File Download History, same thing. We can search or filter on any of these as well. Let's once again pick on CCleaner by searching for CC Setup. You can see quite a few versions of CCleaner were downloaded on this test VM. The timeline is actually a super timeline that's created for us with a huge amount of information here. You can look at the scroll bar and see just how much data that has been assembled here. But this actually attempts to paint a chronological picture of all of the events on the system, much like we would get with log to timeline or something to that effect. Under the tags and comments section, anything that we have flagged earlier, for example, at one point I flagged this as being clean, and you can see it has a tag here, and if we mouse over it, you'll actually see it's clean. If we click it, we can actually change that, but you'll notice this was a particular URL that was visited, and I had marked it previously as clean. So any of our notes or marking related informations and comments will be visible here. And then nothing here under acquisitions. And that's pretty much it. That gives you a great idea of the default set of data that you can expect to see with a comprehensive collector. And again, we could have gone in and changed any of those defaults. We saw what a standard collector collected, which was very, very minimal information. And then again, this is just the default set of options with a comprehensive collector. Any of this we could have easily customized and gathered more information than this or less information, depending on the specific investigation. In my opinion, I would always get everything you can. It's better to have it and not need it than to need it and not have it. So the other thing I would also point out is this is a fantastic tool, but I never rely on a single tool. For example, when I'm performing a memory-related investigation, I would very often use volatility, and then I would compare the same results in Redline and see if they match. Never rely on a single tool's output. It's always good to be able to have several different tools in your belt to be able to go in and verify the information that you're seeing. So that has been an introductory look at Redline. I hope this has been helpful for you. If you're interested in more in-depth videos covering other forensic tools, please do let me know. But again, hopefully this has provided a nice overview of Redline. It's extremely easy to use, all GUI based, so there's no command line arguments and things to memorize like there is with something like volatility. But the tool definitely does have its value. I should mention this is only used for analyzing Windows systems, so you can't analyze, for example, a Linux system with Redline. So again, I hope this video has been informative. If this happens to be the first video that you've seen, I would greatly appreciate it if you would subscribe to the channel. That way you'll not miss any future videos that I release. I tend to create at least 1 or 2 videos a month as I have time. All of them generally relate to either digital forensics and incident response or penetration testing. If you have any comments about this particular video, please do let me know. As always, please like, subscribe, share, and all that other good stuff. And you can also reach me on Twitter at DavisRichardG should you have any feedback. I also often tweet upcoming videos and information relating to that, so you may want to follow me on Twitter if you're interested in this particular topic. But again, I'd like to thank you for taking the time out of your day to watch this video. I hope it's been informative, and I will see you next time.